Why did Iran choose to deploy cluster munitions against Israel? The answer lies in one key objective: overwhelming advanced defense systems. Israel operates the Arrow missile defense system, which is highly effective at intercepting a single large incoming warhead. Iran understood this and adapted its strategy accordingly. Instead of relying on a single payload, they deployed a cluster-based weapon system. As the missile separates mid-air, it disperses multiple smaller submunitions across a wide area. This creates a saturation effect, making it extremely difficult for high-altitude interceptors to neutralize every incoming threat. Due to serious humanitarian concerns, especially the risk of unexploded ordnance, more than 100 countries have banned these weapons. However, not all nations have adopted this restriction. In some systems, similar submunitions can also be launched from 155mm artillery platforms. As each bomblet descends, the impact triggers its detonation mechanism, activating a shaped charge capable of penetrating hardened structures. So, how does it actually reach its target? The flight path is a highly calculated sequence designed specifically to dodge interception and maximize what we call the shotgun effect. First is the launch and boost phase, fired from deep inside Iranian territory, either from an underground silo or a mobile launcher. Powerful rocket motors punch the system right out of the lower atmosphere, setting it on a high ballistic arc toward the Mediterranean. Then comes the mid-course phase. Out here in the extreme upper atmosphere, the missile is just coasting. This is the ultimate make-or-break window. Long-range defense systems like Israel's Arrow 3 have to score a kinetic kill right here, completely destroying the missile while the warhead is still in one piece. Because if it survives and starts its terminal descent, the nightmare scenario begins. At exactly the right moment, reported by the IDF to be around 23,000 feet up, the warhead violently bursts open. This is the free fall and scattering phase. Dozens of submunitions are suddenly released into the sky. Without their own guidance or propulsion, they just rely on gravity and aerodynamics, scattering wildly as they fall. Finally, the impact. Designed with highly sensitive fusing systems, these bomblets detonate instantly upon contact with buildings, vehicles, or the ground, generating multiple shockwaves simultaneously. But from a tactical standpoint, why deploy cluster munitions? In military terms, it's all about overwhelming the enemy's defense systems.
Sophisticated air defense networks like the Iron Dome or David's Sling are incredibly good at tracking and taking out a single intact rocket. But when a warhead opens up at 23,000 feet, that single target instantly shatters into dozens small bombs, becomes difficult to track of high-speed threats. It forces the defense system to calculate and prioritize multiple targets simultaneously, drastically increasing the chances that something will slip through the net. But how does a cluster munition works? A cluster bomb is a type of weapon designed to release multiple smaller explosives known as submunitions or bomblets across a wide area. These bomblets are usually unguided and scatter over the target zone due to the momentum of the main container and the influence of wind. The cluster munition unfurls its ribbon, indirectly semi-arming the shaped charge. It is at this stage that it becomes a lethal weapon, and the inertia weight takes action to detonate the grenade. The United States, Russia, and Iran are among the few countries known to use these weapons. Just as cluster bombs affect civilians, both you and me. Do American cluster weapons stack up against the Iranian ones? Just above it is the propellant added to create extra thrust to reach an estimated range of 29.4 kilometers or 18.3 miles. This is the base of the artillery. It can stack 80 M42 or M46 grenades. That's a lot of firepower packed in this small little artillery. But how can you stack 88 cluster grenades in one artillery shell? If you turn the grenade upside down, it is actually hollow from the bottom. This was designed to fit the shaped charge. It's also one of the reasons they were able to stack the grenades one after another to create more space. Just above it is the pusher plate, which is connected to this expulsion charge cup required to eject the grenade. Finally, at the top is the fuse, often used to arm the artillery shell for different variety of detonations. It weighs 46.5 kilograms, which is pretty heavy considering its size and the 88 grenades stacked inside it. If there's any confusion, this is the size when compared to an average human. This firepower needs a platform to deliver to its designated target. The answer is this 155mm howitzer and the self-propelled Paladin gun. The Paladin is armed with a 155mm howitzer fitted with a semi-automatic loading system. But how do you fire this cluster bomb? Step number 1. Once the fuse is verified, the shell is loaded on this receiving tray. Step number 2. Here, the shell is manually pushed by a soldier inserted with this curved-looking object. Step number 3. A small propellant charge is inserted just after the verified round was loaded. Step number 4. The tray comes back up to make space for the breech ring to close. Step number 5. All said and done, the soldier pulls the lanyard, triggering the primer to fire the propellant charge required for this dual-purpose improved conventional munition. This will propel the shells to a maximum range of fire around 24 kilometers with standard projectiles and 30 kilometers with rocket-assisted projectiles. But what's inside this cluster munition and how it works? The fuse assembly activates the explosive charge. The ejection charge forces the plate outward, causing the outer casing to burst open and release the M42 grenades, as illustrated in the animation. The moment they are dispersed, a nylon ribbon stabilizer deploys instantly, aligning each grenade in a stable orientation and preparing it for the next phase. But that's not all. Due to some clever engineering, the rotational forces at play start unthreading the threaded firing pin from its weight, making the grenade semi-armed. And as the firing pin is pulled out of the slide assembly, things start getting even more interesting. This is where arming the grenade takes place. Now pay close attention. With the firing pin out of the way, the slide assembly becomes free to move. It's like a well-choreographed dance, all thanks to the slide spring and some centrifugal force. These two work together to smoothly move the slide assembly into the armed position. The slide spring ensures that the assembly stays in this fully armed state. Impact and detonation. Fast forward to the impact. This is where the chaos happens. When the grenade hits its target, a specially designed inertia weight takes action. This weight drives the firing pin right into a detonator known as the M55, setting off the firing train. Step number 7. At the firing train ignites, get ready for a spectacular display. A shake-charged jet is propelled downwards while the body of the grenade bursts into a multitude of tiny fragments. Think of it as a controlled explosion that delivers some serious firepower. This jet is incredibly powerful, capable of penetrating around 2.75 inches of solid armor plate. That's some serious punch, destroying tanks and light armor vehicles.
The fragmentation of the grenade body creates a devastating anti-personnel effect. Those tiny fragments we talked about earlier essentially turn into high-velocity projectiles, spreading destruction within their effective radius. It's a highly efficient design that enhances the overall impact of this weapon system. First up, let's look at the battlefield advantages of M42 cluster munitions. These weapons, often referred to as dual-purpose improved conventional munitions, are specifically engineered to disperse numerous submunitions across a wide area. But we can't overlook the serious drawbacks associated with M42 cluster bombs. Let's break down the key concerns. Indiscriminate nature. This is one of the biggest issues. Critics argue that these munitions lack precision, dispersing submunitions over broad areas, including civilian-populated zones. This creates a significant risk to non-combatants, especially children. Unexploded submunitions remain a long-term hazard.
These devices can stay active for years, leading to civilian casualties and slowing down recovery efforts even after conflicts have ended. Potential unintended consequences. The wide area coverage can also result in friendly fire incidents, damage to essential infrastructure, and forced displacement of civilian populations. If you enjoy deep military breakdowns and detailed analysis like this, make sure to subscribe to the channel and turn on notifications so you don't miss the next video.